Yeah, let's start.
Uh, so, good evening, everyone. So, I welcome you all to IIT's Gate classes. Today we will be focusing on the previous year questions asked in flight mechanics, which encompasses both your performance and the stability as well as the control. So, today we'll focus on the Gate 2011, in which they have asked around 8 to 10 questions of varying marks and difficulties. So, my name is Praveen, and let's get started with today's session. So, if you see in GATE 2010, so we had around 10 questions, of which 5 questions were 1 mark, 5 questions were of 1 mark, and 5 questions were of 2 marks. So, thereby totaling to a total of 15 marks, basically, right? So, like I said, okay, you have an average of 16 to 25 marks. So they will obviously focus on this range, because like I said, flight mechanics occupies a big chunk, in your gate paper. So this is an important aspect while preparing for your exams, right? So let's get started with the first question of today's class. So take this question. In an unpowered glide of an aircraft having weight W, lift L, and drag D, the equilibrium glide angle is defined as, four options: tan inverse of L by D, tan inverse of D by L, tan inverse of L by W, tan inverse of W by L. Okay, so this is of a 1 mark question. So let's try to do this. Very simple problem. So in a glide, so unpowered glide means your thrust is zero. Okay, so that's what you have to remember. So again, lift is in this way. Let's take this as a theta, glide angle. Let's say this is my W. So this will be the drag, which means this angle will also be my theta, right? Mind you, theta is my angle of glide, which means that I can write by using force balance. So my L is simply W cos theta, and what about my drag? Drag is simply W sine theta, right? That is, if I try to resolve this into forces, you can see it over here. It moves a different color. So in this way, you will have a W cosine theta. In this way, you will have a W sine theta, and the resultant of which is the W acting at an angle theta. Okay. So let's divide them. So how would you get the angle with respect to L by D? So my sine theta by cos theta is basically what? D by L, right? Basically, it's W sine theta by W cos theta. We're canceling them out. Okay. So which means what? Tan theta is equal to D by L. This implies theta equal to tan inverse of D by L. Or in other sense, I can write theta is equal to tan inverse of 1 divided by L by D. Okay. This is point to remember. Okay. Bracket this, which means if my L by D is maximum, then from this I can say that your theta is minimum, right? This is what is the point that you have to remember. Okay. So if I go back to the answer options, so the correct answer is D by L. That is the thing over here. Okay. Hope you guys don't have any doubts with this, right? No doubts, let me go ahead. It's not A, Rahul. It's B. Okay, so please be careful with that, right? Okay. Because we have a 1 by L by D factor over there. Okay, so mind, please be careful of that, right? Okay. Let's go ahead to the next question. Lift on an aircraft climbing vertically up is, there are four options: equal to its weight, zero, equal to the drag, equal to the thrust. Okay. So underline this word climbing vertically, which means let's take this as the aircraft. Okay. So this is the cockpit, something like that. So an aircraft is going in this way. There is no lift produced because, like I said, no, your wind is coming in this way, so lift is zero in this case. Which means what? As the aircraft goes up, your weight is in this direction, and your drag is also in this direction, right? So which means the thrust produced by the engine, balances both the weight and the drag. Okay, so in that case, your thrust balances your weight and drag. So I just write thrust balances both weight and the drag of the aircraft. So which means what? So lift would be zero, hence the answer is option B, right? Hope you guys don't have any notes in this. Okay, so if no dots, then let me go ahead. Next question, take this one. If an aircraft is performing a positive yawing maneuver, the side slip angle is four options: always zero, is never zero, is always negative, could be any value. Okay, so let's try to do this one. Pretty simple one. Right. So, so first we have to recall, remember the convention. Okay, so the convention is, these are all the positive moments. Okay, nose up is a positive moment, right wing down is a positive moment, and right wing back is a positive moment. And these are all the negative moments. So my nose down is a negative moment, and my right wing up is a negative moment, and the right wing forward is a negative moment. That is, nose up is basically we're talking in this plane. Okay. So this is my basically nose up. Right wing down is, that is, if I basically take an aircraft like this, so right wing back is this moment, and right wing down is, let this be the left and the right wing, and right wing down is the positive moment, and the others are true for the other conventions. Okay, right. So which means if an aircraft is, again, listen to this positive yawing moment, right? So yawing maneuver is what? So which means yawing maneuver is positive, is right wing back, right? So for a right wing back, so from theory, so it is basically, I can write it like this, so dcn by d phi, this is the yawing angle, that is simply minus dcn by d beta. So in other words, for if you have positive yawing maneuver, that is equal to your negative side slip angle. So that is the thing that you should remember. So if it is always positive, so then this side slip angle should be always negative. Okay. So this is comes from the theory. Okay. If you visit AK Ghost lectures, he will provide. I mean, he would have provided an explanation as to why this arises. Okay. This is the theory. Okay. But the thing is, just remember these conventions, and that will help you, solve problems. Okay. Hope you guys don't have any notes in this. Then let me go ahead. Please remember this again. Let me warn you. Please remember this moment convention. Right? So if no doubts, then let me go over to the next question. For an airplane to be statically stable, its center of gravity must always be dash. So I have four options: ahead of the wing aerodynamic center, aft of the wing aerodynamic center, ahead of the neutral point, aft of the neutral point. Think about this. So for an airplane to be statically stable, its center of gravity must always be. So let's do this. First, let's write down the stability equation. So what is my stability equation? The longitudinal direction. dcm by dcl is equal to xcg bar minus xac bar plus dcm fn by dcl minus eta t vh bar at by aw times 1 minus dou epsilon by dou alpha. Where xag bar is, you can, let me just put that in words. The distance, normalized distance, which is the ratio of the distance of the CG from the leading edge to the core of the airfoil. And again, XAC bar is also, same thing. And CMFN is basically the pitching moment produced by the fuselage. And AT is the, lift curve slope of the tail. And AW is lift curve slope of the wing. And epsilon, it's obviously a downwash. Okay? Which means, right, even if your CG lies ahead or behind the aircraft, your airplane can still be statically stable, right? But before going on to let's look at the condition for static stability. Condition for longitudinal static stability. What is the condition is Cm alpha, which is dou Cm by dou alpha. This has to be less than 0 and Cm naught has to be greater than 0. So these are the two conditions. You have to remember that. Okay. So which means even though if this quantity is positive, the negativity of dCm by dCl is ensured by this term over here, right? Because this is a contribution coming from the tail of the aircraft, and this is a contribution coming from the wing of the aircraft, okay? And this comes from the fuselage. So this is what you have to remember, okay? Which means even if the CG is ahead or behind the aerodynamic center, it doesn't matter because your tail ensures. But what matters is your neutral point, okay? Your neutral point is a farthermost location of the CG. Okay, your CG can travel up to the neutral point. Beyond which it can't travel. Right. So you imagine neutral point is like the aerodynamic center. Okay. So which means the center of gravity must always be ahead of the neutral point. Has to be the correct. Okay. Beyond neutral point can't exist. That's not a theoretical case. After the where we get it can exist, but thing is he's asking it must always be. So this cannot hold true as well. And ahead of the advanced center, it because it is also applicable. So, but again, the question that they ask is must always be. Hence, this is also not applicable. So, hope you guys have understood this, right? Okay. Then, if no doubts, then let me go ahead. Please copy this, everyone. Okay. Fine. So you can, I mean, if you miss copying, then still rewatch the videos again by subscribing to get our channel and then rewatch all the videos. Okay. Right. Take this question. Winglets are used on wings to minimize. So we have four options: skin friction drag, profile drag, wave drag, and induced drag. Okay. Right. So let's again do this. So we have to revisit back to our aerodynamics theory. wherein which we studied an important component called as the induced drag, right? Remember? So what is that induced drag basically? So let's say you have a wing airfoil. Let's say a wing. Okay. Right. So closer to the tip. Okay. So what happens is, your flow is basically coming in like this. But what happens is, you have also a span-wise flow, and that will basically cause, a vortex kind of system at the tip, right? So which means what? So this flow, if I look it from this end, this will try to bend the velocity in this way. That is basically downwash velocity. But since my free stream is approaching in this way, v infinity, hence this is my effective downwash angle, which is epsilon or alpha, whatever you want to call it, right? So to minimize this induced drag, so they add winglets such that it cuts off the generation of vortices. Okay, that's what is the use, right? So I can just write it down. The winglets are used to reduce the induced drag caused by tip vortices of the wing by reducing the change in local angle of attack on the wing. Okay, so this is an important thing. So it means what is the use of winglets? It's used to reduce induced drag. Okay, so going by my option, it has to be induced drag option D. Okay, hope you guys don't have any doubts in this, right? Okay. So again, let me just reiterate what I said. So winglets basically, if you see the Boeing 737 Max on A320, you will have those upward vanes at the tip of the winglet. So those are basically winglets. They are used to reduce the induced drag, right? It's a nice piece of engineering done, right? Okay. So then let me go ahead. If you don't have any doubts, take this problem. An aircraft is performing a coordinated turn maneuver at a bank angle of 30 degree and forward speed of 100 meter per second. Assume g equal to 9.81 meter per second square. The load factor and the turn radius respectively are 2 by root 3 and 1.76 kilometer, root 3 and 17.6 kilometer, 2 and 0.18 kilometer, 2 by root 3 and 17.6 kilometer. Okay. Again, this is a simple problem, but let's try to do this. Okay. So first underline what are the given data. So it is performing a coordinated turn maneuver, right? Bank angle is given as 30 degree and the forward speed is given as 100 meter per second. Okay. What are they asking is the load factor and the turn radius. So let's write down given data. So the bank angle, let's identify as 30 degree and the forward velocity is 100 meter per second and the g is 9.81 meter per second square. Which means what I can write from theory that from a level coordinate term that L cos phi will be equal to W and L sine phi equal to mv square by R. So which means what? I can write N as L by W is equal to 1 by cos phi. So this is the general formula for the load factor acting on aircraft in a level coordinate term, right? So if you substitute the value in here, so N would be what? 1 divided by cos 30 degree. So that is simply root 3 by 2. So this will become 2 by 2. This is first information that we obtain. What else is asked is the turn radius. Okay. So turn radius is from this you can just manipulate this, from the equation. You can do that. So I can write R equal to mv square by L sine phi, right? So what is my this thing? M can be written as W by G, right? And this is basically your V square and you also have L sine phi, right? L by W is what we found out now. So which is basically my 2 by root 3. So this would become what it is, root 3 by 2 times V square is 100 square divided by, I have a G which is 9.81 times the sine 30 is 1 by 2. So 2 gets cancelled. So if you solve this, you will get it around 1.76 kilometers. So bracket this again. Which means what? My answer is 1.76 and 2 by root 3. And that is option. Hope you guys don't have any doubts in this. Understood, right? If you have any doubts, please feel free to put it in the chat box, and if you can put in the thumbs up. And if you like the session, please put a thumbs up in the chat box so that will help us to motivate, to organize more lectures like this. Okay. Right. So let's continue with the next question. If you guys don't have any doubts. An aircraft in a steady level turn flight at a forward speed of 50 meters per second suddenly rolls by 180 and becomes inverted. If no other changes are made to the configuration or controls of the aircraft, the nature of the subsequent flight path taken by the aircraft and its characteristic parameters, assuming g equal to 9.81 meter per second square, are. So we have four options: straight line path with the speed of 50 meter per second, upward circular path with the speed of 50 meter per second, and radius of 12.127.4 meter, downward circular path with the speed of 50 meter per second and radius of 127.4 meter, and a downward circular path with the speed of 25 meter per second and radius of 254.8 meter. So again, let's try to do this. Okay, so let's underline certain keywords. It moves at forward speed of 50 meter per second, suddenly rolls by 180 and becomes inverted. Okay, and nature of subsequent flight. Okay, so these two are the keywords that you should remember. Okay, let's do this pretty soon. So you know that in a steady level flight, SNL flight, where SNL is steady and level, my L equal to W, right? Lift is equal to weight, thrust equal to drag. Right? Now he says that initially your aircraft is like this, and after it rolls down by 180 degrees, which means what? It becomes like this, something in here. Right? So it means what? It will try to obviously, follow because it is inverted. So lift is now in this direction, and weight is also in this direction, and that is balanced by my centrifugal force. So that will basically be causing the aircraft to follow a circular path. Okay, that is basically pull down maneuver, right? Which means after rolling by 180 degree, I can write. Let me just take a section of this concerned element. So lift is in this way, and my W is also in this way, and that is basically equal to my mv square by r. So I can sum up the force basically. L plus W will be equal to mv square by r, right? Which means from here I can write r would be equal to v square by g upon simplification. Just how should we do this? Pretty simple. Move this L plus W downwards in here, and since your load factor is 1 because it is not yet changed, so it means my n plus 1 would come in here. So if you simplify this, you will get around. So this is 2g. Or else let me do this, no issues. So let's do that. What you have is, let's simplify this. R would become mv square by L plus W, right? So simplify this. What you have is m can be written as what? W by G, V square by L plus W, right? So let's take that W outside from the denominator as well. So what you have is W gets cancelled. So what you have is V square by G times L by W plus 1. So thing is, we have to first determine what the value of L by W is, right? So what is my L by W? See, he says initially it is an SNL flight, so lift will be equal to weight, so which means L by W is simply 1, right? But note that he's saying, if I go back to the question, if no other changes are made to the configuration, right? So which means you still L by W ratio is fixed, right? So which means what, L by W is still equal to 1, right? And this is obtained from the question, okay? So please be careful. We are not making it up. This is obtained from the question. So we substitute this, so you'll have what? V square by, this is 1 plus 1, so we have 2G. Okay. Hope you guys understood how we got this, right? So it's been substitute all the values, so R will be equal to what? V is 150, right? So 50 square by 2 into 9.8. And you'll get an answer of 127.4 meter. Bracket this again. So basically, it follows a curved path. This is what you have to remember, with a recurved radius of 127.4 meters, right? So let's do this. So my answer is option C, downward circular path with a speed of 50 meter per second and radius of 127.4 meter. Hope you guys understood this, right? Any doubts in this? Okay. So if no doubts, then let me go ahead. Take this problem. An aircraft with a mass of 5,000 kilogram takes off from sea level with a forward speed of 50 meter per second and starts to climb with a climb angle of 15 degree. Put a full stop. The rate of climb and excess thrust available at the start of the climb respectively, assuming G equal to 9.81 meter per second square, are 13.40 meter per second and 13146 Newton, 12.94 meter per second and 12694.1 Newton, 13.4 meter per second and 12694.1 Newton, 12.94 meter per second and 13146.1 Newton. Let's try to do this again. Simple problem. So, what is my rate of climb formula? Recall from performance. My rate of climb is, this is my rate of climb. So, this is equal to V sine, let's say the climb angle to be alpha. Okay, V sine alpha, right? So, what is given? Given that your climb angle is 15 degrees, which means alpha is 15 degree, right? What is this given? At a forward speed, V is 50 meter per second, and my mass is 5,000 kg. Is anything else given? No, right? Let's do this. Okay, so which means what? My rate of climb is, substitute that, so 50 into sine of 15 degree. Simplify this, you will get it around 13.39 meter per second. This is my first answer. Bracket this. And what else is asked? So the excess thrust available, right? So underline that keyword as well. So the excess thrust. The excess thrust is basically, so let's say, you have to understand what the excess thrust is. So on SNL flight, your thrust equals drag, right? And your lift equals weight, correct? Right. So it means excess thrust is basically how much extra component is produced, right, compared to this drag, right? So that is basically, it's given by this T minus T, okay? And that if you determine, I mean, it's pretty simple, you have this body in here, this is thrust, this is drag, this is L, and this is W. If you resolve this in this plane, so my T minus T will be equal to W sine alpha, right? And L will be equal to W cos alpha, right? Basic resolution of forces, okay? Which means substitute all the values in here, so you'll get what? It is 5,000. With M is given, so I have to convert that into W weight, 9.81 sine of 15 degree. And that will come around close to 12695.07 Newton. And if I go back to my answer key, that is option resembles closely to the option C. Okay, because I have a velocity of rate of climb of 13.3 meter per second, and the excess thrust is 12695 I have, so it's close enough. Okay, right. Hope you guys don't have any doubts. Right. And mind you, so in GATE you are only asked, this NAT type question. These questions will come under NAT, so it means you have to feed in the answer, on your screen. So while preparing a key, they will obviously set a range. Okay, so let's say for this answer, they will set it around a tight limit. Let's say 12690 to 12710. Okay, so which means your answer should be within this range. If your answer is slightly off, let's say 12689, it's gone. So which means take decimal places closely. At least take to third order decimal. Okay, that's what I want, right? So you should do that. Don't forget that. Okay, let me go out if no questions. We still have two more questions, and with that we'll wrap up. Okay, so let's take this problem. A glider having a mass of 500 kg is taken to an altitude of 1000 meter with a jeep moving on ground at 54 kmph. Upon reaching the required altitude in 50 seconds, the glider is released and starts its descent. Under the assumption of equilibrium glide, the range and endurance of the glider for a constant lift to drag ratio 15 are. There are four options: 15 kilometer and 1002.2 seconds, 15 kilometer and 601.3 seconds, 1 kilometer and 601.3 seconds, 1 kilometer 50 seconds respectively. So let's underline certain keywords. So the mass is given 500 kg, altitude of 1000 meter, jeep moving around 554 kmph. Upon reaching the required altitude 50 seconds, the glider is released and starts its descent. Okay, and under the assumption of equilibrium glide, underline this. What they're asking is the range and endurance of the glider. Okay, so again, let's try to do this very simple. 12.94. Okay, let me just see that 1 second. Are you sure it's 12.94? Let me check with my calculator. Just give me a minute. Okay, 57, 50 is 12.94. Sorry, guys. I think I made a typo because I prepared this document, then I just maybe I've done some mistakes. Sorry, guys. So it's 12.94. And thanks for bringing this into my notice, Sahil Swastik. So it's 12.94. I know, but the rest is right. It's 12.94 or 12694. Thanks, guys, for bringing this into my notice. Okay. So then let's go ahead and feel free to point out mistakes. Okay. So let's come back to this question again. So what they've asked is to determine the range and the endurance. Okay. Right. So let's do that. So again, if you recap the diagram that I had drawn at the beginning of this session, let's consider an aircraft like this. So L is in this way, D is in this way. Let's say this is my angle of glide angle. Let's say theta. So I found the tan theta to be d by L, right? So in a sense, this tan theta is nothing but what? It is the adjacent side by opposite side by adjacent side. Right? So let's say the opposite is height, distance is the range or the distance that it covers. Okay. Yes. So in a way, I can write this as h by r. Correct. So what is given is equilibrium glide angle. So let's write in the velocity. Okay. So the velocity is 54 meter per second, right? So 54 kmph. So if you convert that into, I think you don't have to convert this. Basically you can just leave it as such. Right? So let's keep it aside. So this height is given as your 1,000 meter, right? Height is 1,000 meter, and so what will be my distance? It says it reaches the required altitude in 50 seconds, right? So which means if you solve that and okay, first let's convert this. So you will get 54 into converted to meter per second. You will do 5 by 18, right? So which means this goes three times. So this will be what? 15 meter per second. Right? So let's keep that aside. So what will be my theta? So theta is basically tan inverse of this d by L, which is equal to tan inverse of h by r, and that comes around to close to 3.814 degree if I'm correct. So which means my range is simply by r is equal to, I can do L by d times h, so we'll have an L by d times h. This will be what? 15,000 meter if I'm correct. Just check this once. Okay. Yeah, because my lift to drag ratio is 15, right? So I'll just write that down over here. So L by D is 15. So I substituted back in here to get theta, right? So substituted 1 by 15, you will get theta. And from this I can get R, which is 15,000 meter, right? So that is basically 15 kilometer. So what about my time? Endurance is basically time, right? So endurance. How will you determine the time? It is basically the height by the vertical velocity, which we call it as a sink speed. Okay, sinking is how far it goes down like this. Okay, and the sink speed is given by this formula. It is v times sine of theta, right? So which is what? It is 15 times sine of 3.814, and that comes around to 0.99 meter per second. Therefore, the time is basically h is what? 1,000 by 0.99, and that comes around to 1002.2 seconds. So please bracket these two values, and if I go back to my answer key, so range is 15 and endurance is 1002. Option A is the answer, right? Hope you guys don't have any doubts in this, right? Pretty simple stuff, right? So just do, I mean, given the data, I just have to manipulate it and get the results. Okay. Right. Okay. So if no doubts, then let me go to the last question of today's session. Please subscribe to our channel, and feel free to post suggestions or your doubts, okay, so that it is resolved, okay? Right. So this is a question. An aircraft in level flight encounters a vertical gust which excites the Phugoid mode. The Phugoid mode completes 10 cycles in 50 seconds, and its amplitude reduces to half of its maximum value in 25 seconds. Put a full stop. The eigenvalues of the Phugoid mode are, so we have four options: minus 0.05 plus or minus 0.02 I, minus zero point 0.5 plus or minus 0.2 I, minus 0.028 plus or minus 1.26 I, minus 0.028 plus or minus 1.26. So let's try to do this. Pretty simple again. So underline the word vertical gust, Phugoid mode. And so we have to use the Phugoid mode formula. If you have watched my last gate session, I have given you the Phugoid formula. So Phugoid motion completes 10 cycles in 50 seconds, and its amplitude reduces to half of its in 25 seconds. Ask this eigenvalue. Let's try to do this. So in Phugoid, the given is time period, right? Time period is basically 50 by 10. So this is basically 5 seconds, right? Because it says, it completes 10 cycles in 50 seconds, since the time period is 5 seconds. So what is my frequency? It is basically 2 pi by t, right? So just 2 pi by 5, and that comes around to 1.257 radians per second. Okay, let's keep that as such. Now, so what is my this thing? He says that the amplitude reduces to half of its maximum value, right? So which means if I use the logarithmic decrement formula, what is that? Delta equal to 1 by n ln of x naught by xn. So which means in 5 cycles, it is reduced to half of it. So which means this will become 2. So that turns around to be, so delta is 0.1386, right? So which means that this is again this delta from your vibrations. I'm basically incorporating vibrations in here so that it is helpful for you. So that is basically 2 pi xi by under root of 1 minus xi square, zeta square. Okay. So which means if I determine the value, substitute this, so which means I'll have 0.1386 equal to 2 pi zeta by under root of 1 minus zeta square. So solve for zeta and you'll get zeta as 0.022. So which means that this is an underdamped one, right? How will you write the roots of the equation? So roots are basically it is minus zeta omega n plus or minus omega n under root of 1 minus zeta square, right? With an I term. So which means substitute that you will get minus of multiplying this with the omega. So we'll have 0.0275 plus or minus I times 1.256. So these are my roots of the Phugoid mode, and that corresponds to back to my option C, which is close, right? Yes, guys. So hope you guys don't have any doubts in this. Again, so problems like these are more to come in the gate exams, forthcoming gate exams. Okay, so what I would suggest you to do is, just revisit your formulas or lecture notes that you have prepared, to revise them thoroughly, and then attend these type of questions because like I said, if you see a question which is very large, that probably will have the smallest step, minimal number of steps required to attain the final answer, right? Whereas if an answer is small, a question is small like this, it will take some steps, 2 to 3 steps to determine the final answer. Okay. So please do attend problems like this and practice problems like this, because get exam, they'll mostly repeat problems and they just end up change the values and play around with it. That's what they can do in gate, right? Okay, guys. So if no doubts, so I thank you all for attending this session and feel free to put questions in chat box. We will respond to you and please subscribe to our channel. And thank you and have a good day. Bye bye.